Welcome guys to Syft Skill with for tomorrow. We'll discuss about quadratic equation today. Quadratic equation. A equation ax square plus bx plus c is equal to 0 is called one quadratic equation. This is of degree 2 and one variable. This is degree 2 and one variable x. We know variables means x, y, z. These are the variables. And constants, suppose a, b, c, these are the constants. So ax square plus bx plus c is equal to 0 is called quadratic equation where a, b, c are real numbers but a not equal to 0. Here is the condition, a not equal to 0. If a equal to 0, it will never be quadratic. It is bx plus c is equal to 0. This is one variable and of 1 degree. So we'll solve now. This has two roots. How will we find? Two roots. Ax square plus bx plus c is equal to 0. If we solve this, we will get two roots. How? Now, ax square plus bx is equal to minus c. We can write this implies x square plus b by a x is equal to minus c by a. Because dividing a in both sides, a not equal to 0 condition we can write here. So we can divide. We can write also here x square plus 2 into b by 2a into x plus b by 2a square is equal to b by 2a square minus c by a. Why? This we are trying to put in a square form to left side. So we have added square of b by 2a in left side and in right side. And minus c by a is there. And here we have written 2 and by 2 because 2 can be cancelled with 1, b by a. We mentioned in this form to make it, this is the square of x plus b by 2a whole square. This is in the form a plus b square. A square plus 2ab plus b square. That is in that form. This you can write b LCM is 4a square and in above b square minus 4ac. This you can write. So x plus b by 2a is equal to plus minus root over b square minus 4ac by 2a is divided by 2a. When square root will be taken, plus minus this portion b square minus 4ac by 2a. So x is equal to minus b by 2a plus minus root over b square minus 4ac by 2a. So if we will take 2a common, we can write minus b plus minus root over b square minus ac by 2a. That is, x is equal to minus b plus minus root over b square minus 4ac by 2a. For plus 1, for minus 1, so it has two roots, x1, x2 say or alpha, beta say. So we can solve this equation x square plus bx plus c is equal to 0 and we could get two roots. But the important thing in this quadratic equation, here we mark b square minus 4ac, b square minus 4ac within the root over. B square minus 4c is called discriminant, D. B square minus 4 is called discriminant. And it depends, the entire roots depends upon D, very important. When D is equal to 0, if B square minus 4ac is equal to 0, discriminant is 0, the result comes minus b by 2a. x1 is equal to minus b by 2a and x2 is equal to also minus b by 2a. Or say alpha or say beta. So minus b by 2a it comes, both the roots are equal when discriminant is equal to 0. And when discriminant is equal to greater than 0, what will happen? If discriminant is greater than or equal to 0, that is b square minus 4ac, if it is greater than 0. That means under this root over, this is greater than 0. If this is greater than 0, okay, if this is greater than 0 and is a perfect square, suppose 1, suppose 4, suppose 9, suppose 16, suppose 25, then exact square root we can find. And under this root over, we will get plus minus, 1 is plus or 1 is minus, then the roots are real, but they are unequal. Real and unequal. The roots will become real and unequal. If not perfect square, then it is not perfect square. So it is, you say it is 3. So it will come root 3 and the root 5 say, suppose root 7 say like this. So entire things it will come in solid wise. That means suppose it may come 2 plus root 3 or 2 minus root 3. If 2 plus root 3 will come, then 2 minus root 3 also definitely will come. Because when the short question arises in quadratic equation, these are two forms. If one root is 2 plus root 3, another root is 2 minus root 3. Remember. So this is also real and unequal. And the third condition, when d is less than 0, when d or b square minus 4ac is less than 0. Less than 0 means under this root over, this is less than 0. It is negative. Negative means root over, suppose root over of minus 1. This is imaginary. And for that, roots will come in complex form. That is, suppose a plus ib and a minus ib. If one is complex, other is also complex, and they are conjugate to each other. They are conjugate to each other. Conjugate means if one root is a plus ib and second root is a minus ib. So this is the conditions of discriminant, and this is very important for the you guys who are appearing in competitive exam. This is very, very important. And remember, the sum of the roots is equal to minus b by a. Sum of the roots is equal to minus b by a. Suppose alpha plus beta is equal to minus b by a. And so product of roots alpha beta is equal to c by a. This is alpha beta and sum, you see how sum of roots is equal to minus b by a and product of roots is equal to c by a. And if alpha and beta are two roots, x minus alpha into x minus beta is equal to 0. In one quadratic equation, ax square plus bx plus c is equal to 0, ax square plus bx plus c is equal to 0. In this form, we can write if alpha, beta are two roots, then x minus alpha and x minus beta is equal to 0. This alpha beta, the alpha sum of roots is equal to minus b by a and product of roots is equal to alpha beta is equal to c by a. And we can write, if we divide here, x square plus bx by a plus c by a equal to 0. And what is alpha plus beta is equal to minus b by a. And c by a is equal to alpha into beta. So, this is one quadratic equation. If we will compare with two quadratic equations, suppose ax square plus bx plus c is equal to 0, and suppose another quadratic equation, ax square plus bx plus c is equal to 0. These are two quadratic equations, and we may find one condition that their root is equal, one root is equal. Suppose they have one common root. They have one common root means, suppose alpha is a root, it is common to them both. So alpha is a root, it is common to them. What condition we can find? And if alpha is a root, then A alpha square plus B alpha plus C equal to 0. And A alpha square plus B alpha plus C equal to 0 because alpha is common to both the quadratic equation. So by solving these two, we can get an important formula, alpha square by BC minus CB. This is small b capital C is equal to minus alpha divided by alpha AC A capital C minus small c capital, that is equal to 1 divided by AB minus small b capital. This is the condition you have to remember. If one root is common, we can establish a beautiful relation between within the formula alpha square by BC minus CB equal minus alpha by AC minus CA equal to 1 by AB minus BA. This is an important formula.